Hello students, welcome to Misostudy, welcome to my class. Today we are going to discuss few questions related to your syllabus, and the chapter is my friend, that is periodic classification of elements. And I have taken few questions from your NCERT book, and strictly the questions are based on your NCERT syllabus. So let's start how to solve the questions. Clear my friend? So look at what is given here. Question number 1. How does the electronic configuration of an atom relate to its position in the modern periodic table? Okay. Now, I'm starting from here. Listen carefully. How does the electronic configuration of an atom relate to its position in the periodic table? As we all know, modern periodic table. Listen carefully. Modern periodic table based on atomic number, and as we know, atomic number is number of proton. If the atom is neutral, then number of proton equal to number of electron, which ultimately leads to the electronic configuration. And in modern periodic table, the atoms are arranged in order of their increasing atomic number. Clear? Now, similar electronic configuration. If two atoms, or you can say two or more elements, suppose if two elements have similar electronic configuration, then similar electronic configuration, that is outermost similar electronic configuration, then they are placed in a same group and will have same properties. Because for example, if I write sodium, as we know, sodium has electronic configuration 1s2, 2s2, 2p6, then 3s1. Look at outermost electronic configuration is ns1. Do you remember this? Yes sir. If I write the electronic configuration of potassium, 1s2, 2s2, 2p6, 3s2, 3p6 and 4s1. This is the electronic configuration of potassium. Look at again that ns1. So sodium and potassium are grouped together. If the number or atomic number increases, that is number of proton, if the atom is neutral, then number of electron increases, then they are placed in a different. For example, first comes sodium, then come magnesium, then aluminum, then silicon, then phosphorus. Because sodium has atomic number 11, 12, 13, 14, 15. So what we can say, the complete explanation, we can say the similar if two or more atoms or elements having same outermost electronic configuration, then they are grouped together and with rise in, and this modern periodic table is completely based on atomic number, and he arranged, that is mostly arranged the atoms or elements in increasing order of atomic number. Clear to you? This is the just explanation. If this question has 1 mark, then you will simply write, that is similar if two or more elements having similar outermost electronic configuration, then they are placed in a same group. Clear? And will have same properties. That's a simple answer. Now next one, helium is an unreactive gas. It is given here, helium is an unreactive gas and neon is a gas of extremely low reactivity. What, if anything, do their atoms have in common? What is the similarity between helium and, that is, neon? As we all know, helium and neon belongs to group 18, and this group is also called zero group. Do you remember? And also called as inert gas. I have discussed this thing during my lecture, inert gases. Clear? Helium comes first, then there comes neon, then argon, then krypton, then xenon, then radon. There are 6 inert gases. What if you write the electronic configuration by cell wise or subcell wise? What do we observe? It has 2. In case of neon, it can be written like this, 2 and 8. As I told you, if any element has filled outermost subshell, then they are stable in nature, or you can say inert in nature. In case of neon, that is, it has 8 electron in outermost shell. That means to say the L shell is completely filled, because L shell has maximum how many electron? 8 electron, and it contains 8 electron. Due to this reason, it acquired inert gas configuration, that is stable gas configuration, stable configuration, which make it inert. Similarly, if I talk about helium, it has 2 electron in K shell, that is K shell is completely filled, because K shell has 2 electron. Due to this reason, it will also have stable configuration. If any atom or element have acquired stable configuration, then they are inert in nature, or called noble gases. So what is common? They have stable electronic configuration, that is their outermost shell are completely filled. In this case, there is a duplet rule, 2 electron, and in this case there is a octet rule. Clear, my friend? This is the similarity. Yes, now I'm going to wrap this part, and let's move to the next question. What is the next question in this case, my friend? Now, this question carries 2 marks. You have to explain how could the modern periodic table remove various anomalies of Mandalay periodic table. Yes. What is the actual answer? As we know, Mandalay's periodic table. Yes, sir. Mandalay's periodic tables were completely based on atomic mass. He arranged the elements according to increasing order of atomic mass and relate their properties with atomic mass. He told that properties of elements are periodic function of their atomic mass. But after the Moseley's experiment, there comes the new table, which is known as modern periodic table. And this modern periodic table, we people know, depends upon atomic number. Yes, sir. That is, now the properties are not related to atomic mass. Properties are related to atomic number of the elements. Am I right? Yes, sir, you are absolutely right. Now, as we know, if we take the Mandalay periodic table, then the position of hydrogen was uncertain. There was no description about the isotopes. There are few pairs. For example, if I talk about if I talk about argon and potassium, argon has more mass than potassium. Potassium has around 39.9 or 39.5 to 39.9 approximately. So argon should placed after the potassium, but argon comes before potassium. This problem was completely nullified by the modern periodic table, because argon has atomic number 18 and potassium has atomic number 19, and he arranged the periodic table in increasing order of atomic number, not mass. Similarly, we know chlorine has 2 isotopes, Cl35, Cl37. That means to say same chlorine will have 2 positions in the periodic table according to the Mendeleev periodic table, because it was based on atomic mass. But this problem was also nullified by the modern periodic table, modern periodic concept, because chlorine has atomic number 17, whether it has mass number, atomic mass 35 or 37, it does not matter. Now look at 17. So isotopes will have same position in the periodic table. In Mandalay periodic table, that is, the position of hydrogen was uncertain. Still the position of hydrogen was uncertain, but we study hydrogen in a separate period, that is group 1 in separate period, that is group that is period 1, that is hydrogen and helium, 2 elements, and hydrogen was taken as considered and taken above the alkali metal in modern periodic table. But it is not true, because hydrogen has similar properties related to alkali metals and halogens. So if anyone asks you, you can take these 2 important examples. Clear to you, and tell them that atomic number here the basics, and here the basis is, my friend, atomic mass. Clear? I think you can easily explain. Now my friend, I am going to rub this part, And one more thing, I have given the complete solution in written in my ebook also. So don't worry, just think the question and check out my explanation, and definitely it will help you a lot. Now listen carefully what is given. Question number 4, name 2 elements you would expect to show the chemical reaction similar to magnesium. As we know, what is the basis of your choice? Yes, as we know, magnesium has atomic number 12. That is, it can be written like this, 282. That is, the valency of magnesium is 2. Clear? Okay. If I take beryllium, if I take calcium or strontium, what we observe, that is, in case of beryllium, the electronic configuration is written like this, my friend, 2 and 2, and calcium 282, and strontium also 288 for the so on. Now what do we observe here? That is, in case of beryllium, the valency is, tell me, in case of beryllium the valency is also 2. In case of calcium the valency is also 2. Yes, in case of strontium, what do we find? We find that strontium has also valency, my friend, 2. Am I right? Yes, sir. If the valency is same, that means to say they will have similar chemical properties. If the outermost electronic configuration, if I write like this, 1s2, 2s2, 2p6, 3s2, this is the electronic configuration subcell wise. Yes, for beryllium what we write here, that is, my friend, 1s2, 2s2. In case of calcium what we write, 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2. In each and every case, what do we observe? The outermost electronic configuration same. If outermost electronic configuration same, then it will have similar physical and chemical property. So what is the basis? Here the basis is valency and outermost electronic, similar outermost electronic configuration. So magnesium will have similar properties with beryllium, calcium, strontium and barium. And one more thing, magnesium is also resemble with lithium also, because lithium is diagonally related to magnesium, but this is the exception, but there is a possibility also. Clear to you? But here the basis is not valency and outermost electronic configuration. This is the anomalous behavior. Am I right? Yes, sir. Now let's move to the next question. What is the next question? The question here is question number 5. Now question number 5 to 8 carry 3 marks. What is given here? Name 3 elements that have a single electron in outermost cell. Tell me. I'm giving you a few seconds. Tell me what is the answer. Only single electron in outermost cell. If I write here sodium, what is right? It can be written like this, 281. It has a single electron. Yes. If I write here potassium, how can it be written? That is 2881. If I write here hydrogen, it can also be written only 1. Look at, name 3 elements that have a single electrons in their outermost cell. Sodium, potassium and hydrogen. If they ask name 3 metals, then do not write hydrogen. You write sodium, potassium, that is rubidium. You can write lithium, you can write cesium, you can write francium. All have single electron in its outermost cell. For example, if anyone asks you to write down the lithium, what will you write? How will you write? That is 2, 1. That is 1 electron. Clear? Yes, sir. Now let's move to the question number 2. That is the B part. Name the 2 elements that have 2 electrons, that have 2, that is TWO, that have 2 electrons in their outermost cell. Okay. 2 electron element. As we know, alkaline earth metals. For example, if I write here beryllium, beryllium has an atomic number 4. It can be written like this, 2 and 2. Magnesium has atomic number 12. It can be written like this, 282. Look at, in beryllium and magnesium, that is, they all have 2 electrons in outermost cell. Similarly, if I talk about calcium, if I talk about strontium, if I talk about barium, If I talk about radium, clear to you? How to find the number? We know magic number, that is 8, 8, 18, 18 and 32. Clear to you? 6 to 8, 88. Clear? Check it out. 12, 20, 38, 38, 56. Okay. Okay, then there comes 6 to 8, 5, 88. They all will have 2 electrons in the outermost shell, and they are called alkaline earth metals. Now let's move to the next one. 3 element with filled outermost shell. We know inert gases, 0 group elements, group 18 elements has stable electronic configuration, that is filled outermost shell. That will be the answer is helium, neon, argon, krypton, xenon and radon. Am I right, my friend? Yes sir, you are absolutely right. These are the very simple questions. Just follow the lectures, follow the NCERT books, sufficient for you to crack the questions, to give the perfect answer of any questions. Now let's move to the question number 6. What is given in question number 6? Why do you think the noble gases are placed in a separate group? That is a good question. Why do you think the noble gases are placed in a separate group? We know noble gases has stable electronic configuration. Noble gases have stable electronic configuration. Yes sir. What I am telling? Stable electronic configuration. And they are, due to the stable electronic configuration, they are generally inert in nature. They do not form any chemical compound except xenon. Xenon is an exception. So we need to study them in a separate group, and this is called group 18 or 0 group or inert group. Clear, my friend? Yes. Question number B. What were the limitation of Newton's law of octave? Yes. As we know, Newton's law of octave, he arranged the element as per the by observing the musical notes like this. That is, after the first and eighth element will have similar properties. That is the case. Yes, like he arranged the element like a musical note: helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. That time inert gas were not discovered. Fluorine. Then there comes hydrogen, hydrogen, lithium, 1, 2, 3, 4, 5, 6, 7, 8. There comes fluorine. Then there comes sodium, magnesium, clear to you, aluminium, silicon. Okay. Then there comes phosphorus, sulfur, chlorine, then what? Potassium, calcium. After that he put wrong. He put here Fe, he put here Mn. Clear to you? That is, Newton's law of octet was valid up to 20 element, that is up to calcium. After that this law does not hold good, because after the discovery of maximum number of element, that this order, that is first and eighth element, this trend was not followed. Because if I talk about the arrangement of lithium, sodium, potassium, then there comes rubidium. If I arrange them like this, then potassium after rubidium, there is a big gap, not 8, because potassium has atomic number 19 and rubidium has atomic number 37. So in this case there is no musical note, that is first and eighth element are followed. So this is for valid for up to calcium. Here Fe is placed with oxygen, not possible. Mn is placed with nitrogen and phosphorus, they all are metals. Aluminium, chromium is placed with aluminium, this is not possible. So these similar elements are placed these similar elements are placed in different group. Due to this reason, this law does not further taken into consideration. What were the limitation of Daubigny classification? What Daubigny told? Daubigny told that is middle element has atomic mass exactly or nearly equal to the arithmetic mean of rest 2 element. After the discovery of maximum number of elements, the law of triads, that is triads rules, were not followed. Suppose if I write here lithium, sodium and potassium, in this case this is correct, but if I write here sodium, potassium and rubidium, check it out, potassium will not have the mass exactly equal to the arithmetic or nearly equal to the arithmetic mean of sodium and rubidium. If I write here fluorine, chlorine and bromine, if I use the same trend, what we get, chlorine will not have the atomic mass nearly equal to the arithmetic mean of fluorine and bromine. But if I take chlorine, bromine and iodine, we find here bromine will have atomic mass. So this law was hold true for fewer elements, and 3 elements are grouped together, which is not possible. Look at lithium, sodium, potassium, rubidium, cesium are grouped together. And this law was not valid for low mass element and higher mass elements also. For example, if I write like if I make pair of FeCO and Ni, what we find, CO has exactly almost equal mass almost equal mass like iron and nickel. These are not arithmetic mean. So this law was hold true for fewer elements also, but after the discovery of maximum number of elements, we cannot follow the triad rule, because in a group there are more than 3 elements. More than 3 elements can have similar properties. Clear to you? Yes sir. Now let's move to the next question. What is the next question? Check it out. The next question is question number 7. What property do all the elements in the same column of the periodic table as boron have in common? As we know, boron has 3 valence electron, 3 valency, or you can say that is 2 and 3. And if I write here aluminium, aluminium will also have 283, same valency. Similarly, if I write gallium 31, it will also have 3 valency. That is, in this group they all have same valency or similar outermost electronic configuration. That is, these are belongs to my friend group 13. Clear to you? And they will have similar common electronic outermost electronic configuration NH2 and P1. This is the common. Now what were the criteria used? What were the criteria used by Mandalay in creating his periodic table? His periodic table was completely based on the atomic mass. He told that periodic properties of element are periodic function of their atomic mass, and he arranged the element in order of their increasing atomic mass. For this, he has taken the oxide and hydride of different elements. The oxide and hydride of, if two elements have similar formula of oxide and hydride, then they are grouped together. So this was the basis, atomic mass and the formula of oxide and hydrides. Clear? Now next one, lithium, sodium, potassium are all metals that react with water to liberate hydrogen gas. Is there any situation in the atom? Is there any similarities? Yes, there is a similarities. All have lithium 3, sodium 11 and potassium 19. All have similar outermost electronic configuration. 1s2, 2s2, 1s2, 2s2, 2p6, then 3s1. Here 1s2, 2s2, 2p6, 3s2, 3p6 and 4s1. All will have similar outermost electronic configuration. That is, all have same valency, that is valency 1. Clear? This is the similarities. Clear? And definitely they will have similar chemical properties also, my friend. Yes. Clear to you? I tried to cover maximum number of questions from NCERT syllabus. Clear, my friend? Now let's move to the question number 8. Now this is a some technical question given, group 16 and group 17. As we know, I am moving here. Group 16 belongs to oxygen family. It is also known as chalcogens. Clear? Ore formation. And group 17 are called halogens. Clear? Yes sir. Now question is, state whether A is metal or non-metal. We know halogens are fluorine, chlorine, bromine, iodine and astatine. These all are non-metals. So what is A? A is, sir, non-metal. Am I right? Yes, sir. Clear? Yes. Now state whether C is more reactive or less reactive than A. As we know, in case of halogens, when we move down the group, the reactivity decreases because fluorine is more electronegative and iodine, if I compare fluorine, iodine is less electronegative. Down the group, electronegativity decreases. Clear? And in this case, we in other words, we can say electron gain enthalpy also decreases. That is, tendency to gain electron also decreases. Due to this reason, reactivity decreases. So whether C is more reactive, we will say C is less reactive. One more thing I am going to mention here. If there is an exception also, down the group electron gain enthalpy decreases, but chlorine will have more electron gain enthalpy, more negative electron gain enthalpy, clear, than fluorine, electron gain enthalpy than fluorine. Always remember, more negative electron gain enthalpy, but electronegativity of fluorine is more than chlorine. Due to this reason, these pair are called black sheep elements. Now the third one is, will C be larger or smaller in size than B? Okay, we know if we move along the period, the size decreases. So C will have a smaller size than B. What will you write? C will have a smaller size than B, because when you move along the period, the value of effective nuclear charge increases. Due to this reason, size decreases. Yes. Clear? Yes. Now, what is the formula of effective nuclear charge? Z effective is equal to atomic number minus screening constant. This is upper level, but still remember this. Z effective is equal to atomic number minus, not 6, this is a symbol, sigma, screening constant. This is called screening constant. Am I right? Yes, sir. Now the next one is, which type of ion, cation or anion, will be formed by elements A? We all know this is non-metal. Non-metal always form anion, my friend. Clear? Yes, sir, definitely. Now I'm going to wrap this part, and now let's move to the next question. What is the next question given here? Check it out. That is the question number 9, 5 marks. Nitrogen atomic number 17 and phosphorus atomic number 15 belong to the group 15 of the periodic table. Write the electronic configuration of these two elements. It's very simple. I have discussed lots of time. Nitrogen has electronic configuration will be written like this: 1s2, 2s2, 2p3. In cell wise, we can write here 2 and 5 like this. This is K and this is L. Am I right? Yes, sir, you are absolutely right. In case of phosphorus, we know phosphorus has atomic number 15. This is written like this: 1s2, 2s2, 2p6, 3s2 and 3p3. Look at nitrogen and phosphorus will have similar outermost electronic configuration, that is ns2 and p3. Clear? Yes, sir, definitely. Now in cell wise, what will you write? That is 2, 8 and 5. That is K will have 2 electron, L will have 8 electron and M will have 5 electron. By graphical, by pictorial representation, that is case. That is, the last valence electron will move here like this. Clear to you? Yes. This is nucleus, my friend. Positive content. This is nucleus. Clear? Yes. Now the next part, which of these will have more electronegativity? As I told you, when we move down the group, electronegativity decreases. Why electronegativity decreases? Because the attraction of nucleus, because the size increases. Look at, the size increases due to this reason. That is the gaining of electron pair from the another atom decreases, my friend. Here also the effective nuclear charge value play a role. but better is due to the increase in size, because effective nuclear charge comes out of your syllabus. Clear? Yes. Now the next one is, how does the electronic configuration of an atom related to its position in the modern periodic table? I have discussed this question in question number 1. As I told you, similar outermost electronic configuration. If two elements have similar outermost electronic configuration, then they are grouped together because they have similar valency, same valency and similar chemical properties. Clear, my friend? Yes. Now let's move to the question number 10. What is the question number 10? Compare and contrast the arrangement of elements in Mandalay periodic table and modern periodic table. As we know, Mandalay periodic table is completely based on atomic mass. Modern periodic table is based on atomic number. According to Mandalay, that is, properties of elements are completely related to atomic mass, but in modern periodic table, properties of elements are directly related to atomic number. That is, similar electronic configuration elements are grouped together. But in Mandalay, there was no such type of electronic configuration. In Mandalay periodic table, that is, there are only 8 group and 6 period. 8 group, that is, further they are in modified Mandalay periodic table, it is further classified as further divided into subgroup like 1A, 1B, 2A, 2B, and group 8 was not divided. After the discovery of inert gases, group 0 is added. But in modern periodic table, we know there are 18 groups and 7 period, my friend. These are the difference. There is Mandalay periodic table, there is no certain explanation of isotopes, but in modern periodic table there is explanation for isotopes also. It removes the anomalous behavior related to Mandalay periodic table, that is potassium and argon I have discussed. So these are the few comparison between Mandalay periodic table and modern periodic table. Now next one is, what property do all the elements in the same column of the periodic table as fluorine having? It's very simple. As we know, if I write fluorine, it has electronic configuration 1s2, 2s2, 2p5. Clear to you? The electronic configuration is outermost ns2 and p5, that is, the valence electron in this case, my friend, 7, and the valency we know, that is 1. If I compare it with chlorine, if I compare it with bromine, iodine, what we observe, tell me? 18, that is 53. Yes, all will have similar electronic configuration, that is ns2 and p5, and they have valency 1 and valence electron, my friend, 7, and they all are non-metals. So we can say that is the valency and the outermost electronic parameter, outermost electronic configuration, that is the common property which we relate fluorine with, which relates fluorine with chlorine, chlorine with bromine, and bromine with iodines. Clear? Okay. Now in written, I have given these things in my ebook also. Go and assess the ebook, and definitely it will help you a lot. So my friend, time has come to say bye bye. Thank you so much.